Unit 3, section number 1. Again, we're looking at law of sines, and now we're actually going to look at the examples. 7a is this example. Now, this is the ambiguous case. This is the angle, side, side. How do I know that? Let me draw a triangle. Every single time I do one of these triangles where I'm given angle, side, side, I'm going to make the angle this location here. Okay, the opposite side is 30, so I have this as 32 degrees. This is the opposite side, which is 30. Okay, let me move this in a little bit. I'm drawing that a little bit small. Okay. And then this side, I'm going to label as the other side. So this is 42. So that means this is angle A, this is B, and this is C. Okay. So you'll notice I'm looking at an acute angle that I'm given. And again, this is side, side, angle. This is the situation I'm given. If I'm given something else, I can work with something else. But right now, I don't. I don't have anything else to work with. So, side, side angle is the ambiguous case. I have B acute. Okay. So if it's an acute angle, that means I have to go to my ambiguous situation cases. Okay. And I'm actually going to look directly here on my notes. Okay. I want to compare A to the height. I want to compare A to the height. I want to compare the height, C and A. And once again, I want to compare A to C. Now, let's start with that. When I say that, A and all those other pieces, what I really want to compare is the opposite side, okay, to all those pieces. Okay. So now I'm going to drop my height down here. I'm going to find out what that is. H. What is H equal to? Well, if I'm looking at the right triangle that's sitting right here, my height compares to B. Well, wait a second. Let me do that. Sine of B is equal to H over, in terms of this 90 degrees, the opposite is 42. Okay? Which means that sine of B is 32. So this is sine of 32 is equal to H over 42. 100% of the time, your height will always be equal to your opposite side. Sorry, not opposite side. The side we don't have anything information with, okay, times the sine of the angle we're playing with. Okay, so there should be a 32-degree mark there. So, what is the height value? I'm going to go ahead and figure out what that is by using my calculator. Okay, in my calculator, I'm going to type the 42 second sine, or for you guys, it would just be regular sine, 32 degrees. This is approximately 22.2566 dot dot dot. Okay. Now, I have my H, okay, which is 20, and I'm going to go ahead and round that off to the whole number. If it's something close to 30 or 42, I would round it off to tell myself that it's either larger than 30 or smaller than 30, or larger than 42 or smaller than 42, okay? Now, again, very carefully, it's the opposite side is comparable in some way. So, the opposite side is 30. The opposite side is 30, and that's greater than 22. So it's greater than the height. Is it also less than this side? Yes, it is. So it's also less than 42. So again, my opposite side of the angle that I'm given, the opposite side of the angle that I'm given, is actually between my height and the side, I don't know what you would call this side over here, but we have the opposite side and we have the extra side. Okay, the extra side we're given. So if it's between the two, what does that tell us? And I'm going to go ahead and look back. Opposite side is less than the height. Opposite side is greater than the height. It's not that one. It's not a possible. Okay, it's not equal. My height is less than the opposite side is less than the side, the extra side. Height is less than, oh crap. Why is that not good? Because there are two possible triangles here, okay? And I have to find them both. This is the worst problem in this section, okay? So now watch what we do here. Okay, very carefully. I'm going to go ahead and find the angles that I need to find, okay? So, this is how this works. I know that there has to be two triangles. Okay? With the two triangles, I'm going to have A, B, B, C, little a, little b, little c. Okay, I'm going to write in the values that I'm given. I'm given 32 degrees. That's not going to change. Okay, and I don't know why this isn't focusing very well. Okay, so I'm given 32 degrees for B. Okay, I'm given 42 for A and 30 for B. Now I also need to find A, C, and C, but I also need to then find A prime, C prime, and little c prime. Sorry, little c prime. Okay, I need to find all of those values because I know that B prime is the same. That's not changing. That's 32 degrees still. I know A prime is 42. That doesn't change. And I know B prime is 30. That doesn't change. So I actually have a total of all of these things to find. Okay, so the way I'm going to do this, and I'm going to do this very carefully, I know that the B and the B match up, so I have 30 divided by the sine of 32 degrees. This is part of law of sines, and I should be able to say that it's equivalent to 42 divided by the sine of, well, I don't know what A is. Let's go ahead and write that in there. This will allow me to find A, okay? So I'm going to go ahead and take this thing, I'm going to solve it for A. So sine of A is equivalent to, it's going to be 42 sine of 32 degrees divided by 30. Again, cross-multiplying or multiplying both sides by sine of A, multiplying both sides by sine of 32, and then I'm going to divide by the 30 on this side to get sine of A on this side all by itself. Okay, that's going to give me this thing right here. I'm going to go ahead and type that into the calculator and figure out what that's supposed to be. But really what I really want is what is A equal to. So if I take the sine inverse of both sides, that's really what I'm looking for. Okay, so again, the sine inverse of both sides. So when I type that into my calculator, I'm going to very carefully do that right now. Sine inverse of 42 times the sine of 32 degrees divided by 30. All inside sine inverse is approximately 40. And again, okay, if it doesn't tell me how to round, I'm going to round to the decimal place that's given. Okay, in terms of my degree measures, I'm given 32 degrees, so I'm going to round to the nearest degree. So 47.892 will round to 48 degrees. So in A, this is 48 degrees. What does that force this angle to be? Well, 48 plus 32, that's 80, so it's going to be 100 degrees there. Okay, and then I can use law of sines to find that remaining C value. Let me go ahead and do that. So I'm going to go ahead and have the it's going to be 30 divided by the sine of 32 degrees is equal to, okay, that's going to be equal to, it's going to be the sine of 100 degrees. And again, we try to avoid using this information, but we're going to go ahead and use this information, okay? And in theory, I really shouldn't have rounded any of this stuff yet to find the rest of the values, but there's no other way to do it. So I rounded the 48 degrees, found my 100. I'm going to use the 100 to find the remaining side, C, okay? Again, multiplying both sides by sine of 100, my C value should be 30 times the sine. I'm not writing it down because I'm typing it into my calculator. 100 degrees divided by the sine of 32 degrees. That's going to give me approximately 55.75. Knowing that all these things are in no decimal places, I'm not going to use a decimal place for this, so it'll be approximately 56. Now I should highlight with the, again, the scribble equal signs like that these are approximately equal to, not perfectly equal to. So there's my first triangle. Okay, this first triangle, okay, is supposed to sit something that looks like this, okay, with 32 degrees here. My A angle over here is actually 48, so it's a small angle, and then the 100 up here. The other one should sit somewhere over here, where this side, and I'm going to draw it in red now, this side is the same length as this side. Okay, that should make a isosceles triangle. Well, if that should make an isosceles triangle, then this angle here, which is supposed to be 48, okay, and this angle here should be 48. But what do I really want? I want the triangle that is made, and I'm going to draw it very, very carefully here, by this right here. Okay, that's what that piece is. So what's this angle right here? That's all I want to know. Well, if this is 48, this angle right here has to be 180 minus that. So every single time we find our second triangle, this angle right here will be 180 minus the angle that we found from before, so 48. Okay, 180 minus 48 is actually going to be 132. Okay, so that gives me my angle for this piece here, and then I'm going to go ahead and add 132 and 32, get 164, and know that this angle right here, 164, is going to be 16 to get the 180. Okay, now these are all approximated values as well, because these values over here are rounded, so these must also be rounded. Then the last thing I have to do is utilize this thing here. Again, 30 over the sine of 32 is supposed to be equivalent to sine of 16 on the denominator and my missing c on top. Okay. When I type that into the calculator, again, very carefully, I'm going to have 30 times the sine of 16 divided by the sine of 32. That's actually going to give me a value of 15.6, which is going to round up to 16. Okay, so these are the degree measures. These are my lengths. Again, this is hands down the worst of these problems in this section. Okay, took an entire page here for this problem. The more you play with these, the easier it will get. Okay, we saw that we had side, side, angle, side, side, angle, side, side, angle. Okay, I used my ambiguous case rule. And that rule is I have to look at the height and compare it to the opposite side. I have to take the opposite side, compare it to the height, compare it to this side over here, and see how they all match up. If the opposite side is between the two, then I have two different triangles, and I have to solve them both. Okay, the A prime, B prime, and so on and so forth prime. Okay, the prime triangle. Okay, and the original triangle. Yes, both of these are your solutions. I must see all of these values in your answer. Okay, we will finish up these the last two problems in one more video.